New Zealand produces a staggering 21 billion liters of milk every year. It's the 9th largest dairy-producing country in the world, and it accounts for 3% of the world's milk production. For a country of its size, that's a huge contribution. But this comes at a cost, a very high environmental cost. 11,000 liters of water go into producing just 1 liter of milk. First up, dairy farming is big business in New Zealand. The bigger the business, the bigger the environmental impact. Dairy makes for the largest sector of goods export in the country. This translates to 1/3 of the earnings from the export trade. Dairy is the largest export goods sector in New Zealand, accounting for $1 in every $3 that New Zealand earns from the goods export trade. The Fonterra company is the biggest contributor to the sector. It's a cooperative owned by some 10,500 New Zealand farmers and is responsible for about 30% of the world's dairy exports. Its chief executive, Miles Hurrell, has said that the demand from China and Southeast Asia will continue to rise. But it's important to consider what kind of impact such high production levels have on the environment. One is through looking at the carbon emissions, and the other is looking through how it impacts water scarcity and water pollution. Next, milk production causes water scarcity and water pollution. The issues of water scarcity and water pollution are critical global issues. Water scarcity is not caused only by shortages of water. It also stems from the fact that fresh water becomes unusable because of pollution. This is increasingly the case in New Zealand. New Zealand now has the highest per capita usage of water for agricultural purposes among the OECD countries. That's the Organization for Economic Cooperation and Development. On a governmental level, regulatory failures have led to an overallocation of ground and surface water resources. Some of the water sources in New Zealand are bound to become unusable in the near future. Given the intensification of agriculture and horticulture, the nutrient and sediment emissions into waterways have increased many-fold. While the grass-fed dairy models does have its environmental benefits, it does have some drawbacks as well. New Zealand's outdoors dairy farming system has led to a situation where nitrate leaching from animal waste and synthetic fertilizers has contaminated perfectly good fresh water. And now for the grey water footprint of milk production. A paper published in the Australian Journal of Environmental Management outlines and measures the grey water footprint of milk caused by nitrate leaching from dairy farms in the area of Canterbury, New Zealand. A water footprint measures just how much fresh water is used to produce a certain mass or volume of product, in this case, milk. A water footprint consists of consumptive and degradation components. The consumption component consists of rainwater. This is called a green water footprint. The other component is groundwater or surface water. This is called the blue water footprint. Grey water consists of the degradation part. This is the volume of water that is required to dilute the pollutants produced. This must be done to the extent that the water remains above the required water quality standards. When considering the water footprints of various food systems, the focus tends to be on the consumptive water component. The degradation component, that is, the grey water, is often ignored. However, in the paper published by the Australasian Journal of Environmental Management, it was found that the grey water was the biggest part of the water footprint. Up next, 11,000 liters of water needed to meet guidelines. In the research, it was found that the nitrate grey water footprint for the Canterbury area of New Zealand ranged from anywhere between 433 liters to a staggering 11,110 liters of water for every liter of milk produced. That is a lot of water. And given the extent of water scarcity around the world, this seems terribly high. The number of liters of water required depends on the water standards and the accepted nitrate thresholds. 433 liters is what's required to meet current drinking water limits, while 11,000 liters are required to protect aquatic ecosystems. This is much higher than the corresponding figures for milk production in other parts of the world. The footprint depends on the feed and fertilizer used and the water quality standards set by regulators. An earlier study of dairy water footprint in the same area of Canterbury gave a number of 400 liters to produce 1 liter of milk. However, it was only using the New Zealand drinking water standard for nitrate nitrogen. This ended up underestimating the actual problem, and now a drastic reduction is needed. And by drastic, we mean a 12-fold reduction is needed. The huge water footprint in Canterbury suggests just how milk production has overextended the capacity of the environment. To maintain current levels of production and have good, clean, healthy water, 12 times the amount of current rainfall would be required in the region. Alternately, the number of cows would have to be reduced 12-fold. This level of intense dairy farming is not sustainable. Half of New Zealand's waterways exceed the nitrate nitrogen level indicated for the development and maintenance of healthy ecosystems. There's also evidence for the direct effect on human health of the high level of nitrate in drinking water, including colon cancer and birth defects. Dairy farming in Canterbury has already led to a high level of pollution in the area's groundwater. Most of this groundwater is used for drinking water. Water scarcity and water pollution are issues that are affecting populations and ecosystems around the world, not just in New Zealand. Let's take a look at other environmental news from around the world. Starting with Italy's breadwinning river is under threat. Po is Italy's longest river and its main source of water. The main source of the river is from the Cottian Alps. It runs through an area of 662 kilometers, and it ends in the Adriatic Sea. For the last 20,000 years, Po has been been feeding the expensive fertile plains of northern Italy and generations of farmers, contributing to 40% of Italy's gross domestic product. These lush fields are Italy's breadbasket. Recently, the residents of the surrounding city discovered a golden sandy beach. This seems like a nice place to walk their dogs and relax, but it is actually an alarming situation, signaling the falling water level of the river. The river water level has dropped so low and has created a vacuum where the salty waters of the Adriatic have started pushing in. It's a grave situation for the surrounding farmland, so heavily dependent on the river water. The salt water seeping in can turn this rich, fertile flatland into a salty wasteland. This could be a huge blow to the country's economy. This situation is caused by climate change. In the last 20 years, the Alps have received 50% less snowfall than usual, thus reducing the supply from the Alps, which are the actual reservoirs for the Po. Usually this area receives at least one every 2 weeks, and now it has been months since the last rain. Next, there is a 50-50 chance of breaching the 1.5 Celsius warming limit. According to new analysis, we are heading towards crossing a key warming threshold. Researchers at the UK Met Office said that there is a 50-50 chance the planet will be 1.5 degrees Celsius warmer in the next 5 years. This may be temporary, but scientists and researchers are concerned about the overall direction in which the Earth's climate is headed. Warming gases have built up rapidly over the last 3 years, and temperatures around the world have gone up consequently. The UK Met Office researchers said that it is certain that the period between 2022 and 2026 will clock the hottest years to date. For the last 7 years, temperatures have stayed at 1 degree Celsius, and 2020 being the hottest years in recorded history. Even at this level, the world is seeing considerable impact, such as the wildlives of North America and the current heat waves in India and Pakistan. However, the latest update suggests that the chances of crossing the 1.5 degrees Celsius mark stands at 48%. Temperatures between 2022 and 2026 are projected to be anywhere between 1.1 and 1.7 degrees higher than pre-industrial levels. And finally, climate change will lead to a decrease in essential omega-3 fatty acids. We are well aware of the effects of global climate change. It has resulted in the loss of polar ice, leading to a rise in sea levels, not to mention the intense heat waves. A survey conducted of planktonic lipids in the ocean suggests a decrease in the production of essential omega-3 fatty acids. This is linked to high temperatures. As global warming gets more severe, the plankton at the bottom of the food chain will be producing much less essential fatty acids. This in turn means less omega-3 fatty acids for fish, and consequently for humans. The experts predict significant declines in the essential fatty acids called EPA. It is considered to be one of the most nutritious omega-3 fatty acids. It has a wealth of health benefits and is widely consumed as a dietary supplement. The researchers went on to say that these phenomena are yet another example of how human activities are disturbing the oceans in ways that we never thought possible. There is also a lot of uncertainty around how the ocean is going to respond to global warming. That's a wrap for this video. Thanks for watching. We'll see you in the next one.